Hello. A part of Calculus 2 course is talking about the calculation of surface area and length of the arc of a function that can be rotated around one of the axes or any straight line. In our case, we are given the function of x equal radical x between the points 1 and 4. We are asked to find the surface area after revolution the arc between 1 and 4 around the x-axis. What we are going to do first is to show this figure in GeoGebra application. This is the curve that we are talking about, which is the arc that will rotate about the x-axis. And if we rotate it about the x-axis, we will get the part here, which will be a truncated cone, as you see here. So what we are going to do is to calculate the surface area of that shape that we see here. The formula for the surface area tells us that surface area of revolution is equal to 2 pi integral from 1 to 4, which are a to b here, f of x radical 1 plus f prime of x power 2 dx. If you want to exactly understand how this area formula was formed, there will be a video in SPI-MATH talking about the surface area and why it is written in this form exactly. For our case today, we will focus on the calculation of the area and solving the integral. We will start by substituting everything we have in our question. So this is the 2 pi integral from 1 to 4 of radical x times radical 1 plus, here we will put f prime square. We have f of x equal radical x. So very simple calculation in calculus will let you know that the derivative is 1 over 2 radical x. Then we will substitute it here, 1 over 2 radical x. This gives us the integral 2 pi integral from 1 to 4 of radical x times radical 1 plus 1 over 4x dx. How can we calculate this integral? When we look at the integral in the beginning, it does not look very simple to take a change of variable, for example, by using U substitution. For this reason, a small algebra can help you understand this question easily. These are square roots multiplied, so I can just make them one square root and multiply the x inside by this, which will give you x plus 1 over 4 dx. How did this happen? I just multiplied x into 1 plus 1 over 4x, which gave x plus x over 4x. Canceling x's together, this will give x plus 1 over 4. There are two ways to solve this question, either by using direct formula, which tells us that integral of any linear function power n, if we have ax plus b to power n dx, this will give you 1 over a times ax plus b power n plus 1 over n plus 1 plus c. If you don't like to deal with the fractions, you can write this integral in a simpler way. It can be written as 2 pi integral from 1 to 4 of radical 4x plus 1 over 4 dx. And here the radical can be distributed over the fraction to give us 2 pi over 2 integral from 1 to 4 radical 4x plus 1 dx. By letting u equal 4x plus 1, we can get du to be 4 dx, which means dx is equal 1 over 4 du. So what happens now? I can cancel the 2 out. The new integral will become a equal pi integral. Now we need to be careful for these bounds. These bounds are for the variable x. When we substituted u, we have to calculate in u values. For x equals 1, this will give you 4 times 1 plus 1, which will be 5. And for x equals 4, this will give me u equals 4 times 4 plus 1 which is 17. So my new bounds are 5 and 17. Now with respect to du, not dx. And under the radical, this is just radical u times 1 over 4 du, which was dx as we have seen here. Now the integral became a very basic integral and very simple to deal with, which will become 1 over 4 or pi over 4 of u power 3 over 2 over 3 over 2. I just added 1 to the half power, which is the radical, between 5 and 17. This gives pi over 4 times 2 over 3. 17 to power 3 over 2 minus 2 over 3, 5 power 3 over 2. Finally, I can multiply 2 over 3 outside, which will be pi over 6, 17 radical 17 minus 5 radical 5. So just to clarify, 17 power 3 over 2, which is 17 times 17 power half, it is 17 radical 17, which is the normal rule of powers. X power radical power 3 over 2 is x radical x. This is the answer for some unit power 2 because we are calculating area and this area is clearly a positive number. For more complicated expressions and integrals, we will see more videos in our website. Thank you for watching.